So for topic 3, we want to find the x and y intercepts and the vertex of a parabola. If you're following the pacing guide, it just says finding the x-intercept. I didn't like that. I think it's good to know how to also find the y-intercept. So that's what we're going to add that on today. So first recall, how do you find the x-intercept and your y-intercept? Your x-intercept, so x, I'm just going to say it is when y is equal to 0. So you let y equal to 0 and then you solve for x, and those are your x-intercepts. And then for y-intercept, what do you think? It's when x is equal to 0, right? That makes sense because an x-intercept, so I'm just going to use a linear function because I think those are just easier to talk about. So your x-intercept is wherever your function crosses your x-axis. And so when it crosses our x-axis, what does it tell us? This tells us that y is 0. It is only touching the x-axis. And if you look at the points here, like even over here, if we call it negative a, what is the point? It is going to be negative a, and then because it goes to the left a unit, and then y is when it goes up or down. But in this case, it stays put. So what does that mean? It moves 0 units. Same thing for the y-intercept. This y-intercept is when x is equal to 0 because when we look at, so for example, when we put, when we're plotting points, so as you can see, if it's up here, we don't move left or right to find this point. So it's going to be 0. But then we go up, okay, and we can just call this a. And this would be 0a. Right? So that's why you plug in 0 into y when you want to find the x-intercept, and 0 into x when you want to find the y-intercept. Right? So one thing I want to know for a quadratic equation, so when you have linear equations, you always have one x-intercept and one y-intercept. But that's not the case for a quadratic function. For a quadratic function, you can have 0, 1, or 2 x-intercepts. So what do I mean? So, for example, it can have 0. So if my graph looked like this, or we had, when we did our example before, we had a graph that looked like this, it never touches the x-intercept. But when you talk about one intercept, it's like our parent function. Our parent function only has one x-intercept. It's because so usually when it is one x-intercept, that is the vertex itself. Right? It just lightly touches and then moves off, right? And then our second option is when we have two x-intercepts. And what is that? That is when our x-intercept is like this, or it can also, it doesn't matter, it can also look like this, right? It crosses twice. Same thing for this. I didn't put another example. It can also look like this. So I know I put a lot of graphs on this one thing. I apologize, but hopefully the colors help decipher. Right? So those are the three options for a vertex, or for your x-intercepts. But as you can see, we're always going to have one y-intercept. Why is it y-intercept? So it's because the range of a parabola is from that. You're always going to have an x-intercept, right? And then you're not going to have two because f is a function of x, right? So since it's a function, what do we know? It can pass the vertical line test. So what does that mean? It cannot have two y-intercepts because if it did, it would not pass this vertical line test. So there's always one y-intercept, right? So now let's do our example. Okay, so maybe let's erase this nonsense so it doesn't distract us. Right, so our example, we have y is equal to x squared minus 2x minus 3. What are our directions? Our directions are to find the x-intercept, the coordinates of the parabola. I didn't add the directions, but I didn't edit it, but we should also find the y-intercept. So first things first, we're going to find the x-intercept. How do I do that? I'm going to plug in 0 for y. So this is 0 is equal to x squared minus 2x minus 3. And what do you know? We got a factor, right? It's just never going to leave us. So it factors into this, right? If you check it out, you'll get the function above, or the equation above, right? So using the zero product property, we know that x minus 3 is equal to 0, or x plus 1 is equal to 0. So our x-intercepts, so x is equal to 3 and negative 1. So what is that? Our x-intercept, 3 and negative 1. How would I want to write this if I asked you for a point? So if I said x is what is a point correlated to the x-intercept, it is going to be 3, 0, and then negative 1, 0. Right? Remember, we plugged in 0 for y. Right? So now, before we find the vertex, I want to find the y-intercept. Okay, so how do we find the y-intercept? We want to plug in 0 for x. So we have y is equal to 0 squared minus 2 times 0 minus 3. Okay, so y is equal to negative 3. Right, that looks terrible. Let's rewrite that. Okay, and again, if I wanted to rewrite this as a point, it is going to be 0, negative 3. Let's try one more time. Right? So now, what are we going to do? Our last thing is we want to find the coordinate of the vertex for the parabola. So as you can see, it does not say put it in vertex form. So what can we use? We can use the vertex formula. So what is it? It's going to be the negative b over 2a. I'm going to use, actually, I'll show you guys both to show you that it doesn't matter what you pick, right? So I'm going to erase this so I can keep my example right here, right? All right. So first, I'll just do the negative b over 2a and then the 4ac minus b squared over 4a. Right? So first things first, what is a, b, and c? A is 1, b is negative 2, and c is negative 3. Right? So we're just going to plug this in. So negative b over 2a, this is negative 2, 2 times 1. So this is positive 2 over 2, which gets reduced down to 1. And then if we do 4ac minus b squared over 4a, this is 4 times 1 times negative 3 minus b minus negative 2 squared all over 4 times 1. So 4 times 1 times negative 3, that is negative 12. Negative 2 squared is positive 4. And then I'm going to put, this is minus 4 because of the minus right here. Okay. So this negative 12 minus 4, that is negative 16 over 4, and then this is negative 4, right? So what is our vertex? Our vertex is 1, negative 4, right? So that was kind of long. So now your second option, right? Trying to find it. Okay. So your second option is the negative b over 2a, and then just plugging that value into our function, right? So I just think that this is a lot easier to memorize. So again, I'm not going to recompute it because it's computed up here. Negative b over 2a we have determined is 1, right? So that is the best number to have, besides 0. So now what are we going to do with this 1? We're going to plug it into here. So y is still equal. It is still a function of x, right? So let me just bring my work up here. So okay, since this is a function of x, I can just write f of 1. Okay, what is that? That is 1 squared minus 2 times 1 minus 3. This is 1 minus 2 minus 3, okay, which is negative 4. See how much easier that was? It's just, whew, not even bad at all. So as you can see, we still get the same answer with a whole lot less of work. Right? And that is the end of topic 3.